Hello, my name is Roberto Mora, and today we are checking out how to go from a second degree equation that it's not factorizable from a general form. General form would be the one of ax squared plus bx plus c, and we're going to a vertex form that is the one that is right here. So we're going to use the method of complete the perfect trinomial square to go from this general form to vertex form. First, let's see directly from that general form, which data can we infer from there. So we know that c is equal to 10. From c, we obtain the y-intercept every single time, because the y-intercept is the value when x is 0, and when x is 0, the first two terms disappear, and pretty much y is equal to 10. So we know in 0, 10 should be the coordinate of the y-intercept, and indeed it is. It's right here in this green point, 0, 10. To find the x-intercepts, we're going to apply this method of completing the perfect trinomial square. And we're going to follow the steps that we did in the video before in Spanish. So first of all, we are going to equal, because we're finding the x-intercept, so the equation minus 2x squared plus x plus 10 has to be equal 0. And then we have to clear the term c. So we're going to get rid of that 10, and we obtain minus 2x squared plus x equal to minus 10. That would be our step 1. For the step 2, we need to get rid of that minus 2 to have an a equal to 1. So pretty much the term x squared has to have a constant 1 next to it, not a minus 2. So the process we follow is that we factorize with maximum common factor. That's minus 2. The first term is going to have x squared alone. The second term has to change the sign, and because it doesn't have a 2, we factorize the common factor as 2 underneath. Think about it as the opposite operation. That 2, if it multiplies the x squared, it should be equal to minus 2x squared, so it is correct. And then if that minus 2 multiplies the fraction right there, we would obtain a minus 2 multiplying a minus 1 over 2, that it's equal to a plus 1, that it's the term we have right here. So it is correct, our factorization, and that equation still it's equal to 10. And this 2 that it's right here is going to go to the other side of the equation, dividing, or the same thing as dividing minus 2 in both sides. So the equation can be inferred as x squared minus 1 over 2x equal to minus 10 over minus 2, that is the same as 5. After that, we have our step 3, that is to actually complete the perfect trinomial square with the formula b over 2 squared. And if we substitute b, that it's minus 1 over 2, we know that minus 1 over 2 again, that 2 it's over a 1, and all that is squared. So if we apply sandwich law, we know the 2 in the middle are multiplying, so that should be equal to minus 1 over 4 squared, that it's equal to 1 over 16. That 1 over 16 is going to be added to both sides of our equation right there. Let's rewrite that as x squared minus 1 over 2x plus 1 over 16, and on the other side we have the positive 5 plus the same 1 over 16. So let's do this addition of fractions right now, 5 plus 1 over 16, that it's equal to a denominator 16. 5 times 16, it's equal to 80, plus 1, that's equal to 81 over 16. The factorization of that trinomial, it's a binomial squared, because just what we did, it's finding the perfect trinomial squared, so it has to be. How do we check this binomial squared if it's correct? We just square the corners, and if we actually multiply the middle, or if we add minus 1 over 4 plus minus 1 over 4, we actually obtain the minus 1 over 2 that it's in the middle. So this factorization is correct. You can check it if you want to, and that's equal to 81 over 16. That is the addition of those fractions that we obtained just before now. So from here we can obtain the values from x, because we can clear this square. We can just clear it to the other side as a square root, and that's equal to x minus 1 over 4 equal to the square root of 81 over 16. Remember that any square root for this method is going to be a positive and negative number, and from there they're going to come our two different answers, our two different x's. Okay, so x1 is going to be equal to the square root of 81, it's 9, and the square root of 16, it's 4. So a positive, the first sign, a positive 9 over 4, and then we're gonna add the minus 1 over 4. It's gonna go to the other side as a plus minus 1 over 4. We're isolating this x right here, so plus 1 over 4, and that's equal to 10 over 4. That it's, we can simplify it as 5 over 2. That it's indeed this 5 over 2, 2.5. That is the first y-intercept. So that it's the same as our first x, and it's correct. Let's just check our x, our second x. That is going to be the same one, but now we're going to be using the minus for the answer of the square root. So we're going to have a minus 9 over 4, a negative number now, and again plus 1 over 4. Because it has the same denominator, right away we know that's equal to minus 8 over 4, and that's equal to minus 2. And indeed minus 2, it's the other x-intercept that we have right there. So this would be our x2. So the x-intercept are those two coordinates. So it's gonna be, because it's x-intercept, the one that has the value is the x, so it's the 5 over 2 and the minus 2. 5 over 2 minus 2, and y in both cases it's 0, and it's the same as the coordinates we have right there. So it is correct. Because we use the method of completing the perfect trinomial squared, from right here we can actually go to vertex form, that it's one of our objectives, to actually know the value of the vertex. So we want to go to the vertex form from this equation that we obtained right here. So first of all, we need the number that is next to the parentheses, and according to the vertex formula, it's a. And a, we got it from the very beginning, from the general form. So a should be equal to minus 2. So if we want to have a minus 2 right here, we need to multiply it in one side, and necessarily we need to multiply it on the other side. So if we do that operation, we obtain minus 2, the parentheses from the beginning, x minus 1 over 4, our binomial squared, right there, and that's equal to minus 81 over 8. Okay, so minus over 1 of the 8, we just have to isolate it on the other side to obtain the second coordinate of our vertex. Therefore, we know that minus 2x minus 1 over 4 squared plus 81 over 8, that's equal to 0 or equal to f of x. That equation right here is our vertex form, okay? So from there, we know that always the term right here inside of the parentheses is the x coordinate, but with the opposite sign, so it's going to be 1 over 4, and the other coordinate is 81 over 8. That is the vertex. It comes from these numbers in the vertex form, and indeed they are the two coordinates that we have right there from our graphic. The axis of symmetry, remember that it's always x because we're talking about vertical line, and that imaginary vertical line, it passes through the vertex. Which coordinate of the vertex? X. So the dot 25 that we know it's 1 over 4, the fraction, that should be equal to x, and that's the axis of symmetry. If we graphic that equation, x equal to 1 over 4 would be the pointed line of the axis of symmetry, okay? The domain of this quadratic equation is minus infinite to infinite. The range, it goes from minus infinite, because this one continues all the way to minus infinite, till our y coordinate, that is 10, well, the fraction is 81 over 8, so let's write the fraction, 81 over 8 with a bracket. Remember that we can write those also as inequalities. In this case, there is a maximum value. Why maximum value? Because the peak, the vertex, is on top of the quadratic function. So we have a maximum value of the same coordinate as the vertex, the same order pair, 81 over 8. Check out that from left to right, from the minus infinite to the vertex, the equation is increasing, increasing, increasing. So the increasing interval has to be from minus infinite to the x, the 1 over 4, the x point, the x value for the vertex, that dot 25, 1 over 4. And then exactly from there it starts decreasing, 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 decreasing. So the decreasing interval has to go from 1 over 4 to infinite. Remember that we put parentheses because 1 over 4, that is the vertex, is neither increasing or decreasing. Finally, we have our positivity. So where is this graphic positive? Above the x-axis. So check out that our reference is always the x-intercept. And we know that exactly that interval in yellow is where the graphic is above the x-axis. So from minus 2 to 2.5, the graphic is above the x-axis. So that's the positivity. From minus 2 to 2.5. We do not include those points because at those points the output is the y, the output is 0, and 0 is neither positive or negative. And for the negativity, we have that from minus infinite to the first point, the first x-intercept, that minus 2 right there, it's negative, it's below the x-axis. So from minus infinite to minus 2, we have negativity from that quadratic equation, and we have to make a union to the other side. So from 2.5 to the rest, to the infinite, we know that the graphic is going to be in a negative section below the x-axis. So from 2.5 to the infinite, again we are on the negative side, so this part is part of the negativity. Okay, so I hope you enjoyed the video, and I hope you followed step by step to actually have all the answers in a bigger section than the one that I have right now in the board. So I'll give you the link of the Graphicator if you want to put any quadratic equation in a graphic calculator. And let's be in touch. If you have questions, let me know. You can write me right here. See you later.